So we see that today deep learning is a very important aspect of machine learning because of its inherent nature of being able to capture several unstructured data forms as inputs. If you look at deep learning as a enabling ML technology, the underlying concept today, which is a building block of deep learning, is the concept of neural network. If you see the concept of neural network, the basic idea originated from being able to capture what a biological nerve cell or a neuron would be doing in the brain. The idea is to mimic its functionality. So the simplest form of neural network invented in deep learning was what is known as single layer perceptron, which is the first form of neural network which remained the main source of formation of all kinds of programs which wanted to build neural networks. Let us look at what a single layer perceptron does and see how we can use single layer perceptron to represent different functions like input-output combinations. A single layer perceptron is based on the idea of there is some set of input nodes, then there is something known as an activation node, and all input nodes are connected to the activation node with some weights. Then there is something known as a constant node or a bias node, and there is something here known as a threshold function in the thresholding unit, or what is known as a TLU, threshold logic unit. So this is something known as a TLU. These are input nodes and these are a bias node, and together this whole function is represented by first sigma of Wi xi plus b is the input that is coming in here, and then it is passed to the thresholding function, which actually differs whether if the sum is greater than equal to 0, then output 1. If sum is less than 0, output 0. So the output of a single layer perceptron, which is made up of a threshold logic unit, would be based on different inputs being provided to it, and internally the logic would be performing sigma of Wi xi, and to add that the bias function, find a sum, and then apply the thresholding function, which says that if the sigma of Wi xi plus b is greater than equal to 0, give it 1. If it is less than 0, give it 0. Now, let us take an example of how this is useful for computing a function. Let us take, for example, if you say x1, x2, and let's take, say, the OR function. What does OR function do for x1, x2? x1 0, x2 0, OR function will give you 0. x1 1, x2 0, x1 0, x2 1, or x1 1, x2 1, all of them will give you 1. Now, can you devise a threshold logic unit which represents the OR function? Let's try it here. Suppose we talk about x1 and we look at the output function, there is a bias function. Now suppose x1 is, suppose the bias is -2, right? And we want x1 and x2 to be input to this threshold unit. And w1, let's assume it is both 1. So 1 plus 1 minus 2 is 0, which is greater than or equal to 0. It will give you 1. But what about 1 plus 0? 1 plus 0 will be 1, minus 2 will be minus 1. But we want it to be giving 1, right? So what we want to do is, let's say we want to create it as minus 1. Let's try it. 1 plus 1, 2, minus 1, 1 is greater than or equal to 0. So it will give you 1. Fine. 1 plus 0 is 1, minus 1 is 0. 0 is greater than or equal to 0. It is giving you 1. 0 plus 1 is 1. 1 minus 1 is 0. 0 is greater than or equal to 0. So it will give you 1. Now let's say 0 plus 0. 0 plus 0 minus 1 is minus 1. So minus 1 is less than 0. So it will give you 0. So now here we have a threshold logic unit function which is very similar to mimicking a OR function. So that is the power of neural networks. So earliest form of neural networks was in form of what is known as single layer perceptrons or threshold logic units, which were used to approximate a function by means of representing the corresponding weights and the bias function. By manipulating the different combinations of the weights and the bias, you can approximate the corresponding digital function which you want to be approximated by the corresponding neural network. So this was the first form of neural network ever invented, which formed the basis of deep learning. We can similarly look at modifying this to create, say, an AND function. What's an AND function? AND function would become 1 and 1 will become 1, 1 0 will become 0, 0 1 will become 0, 0 0 becomes 1. And now suppose instead of minus 1, I make it minus 2. Now let's see what happens. 1 plus 1, 2. 2 minus 2 becomes 0. 0 is less than or greater than or equal to 0, so it becomes 1. 1 plus 0 becomes 1 minus 2 minus 1, so it becomes 0. 0 plus 1 minus 2 minus 1, it becomes 0. 0 plus 0 minus 2 minus 2 is less than 0, it becomes 0. So now we have a modified version of TLU which now represents the AND function. So now you can see the power of the threshold logic unit based approach to single layer perceptron, which is the basis for what is called as a deep learning first principles, and this formed the first kind of neural networks that were ever invented in the history of what we call as deep learning. So you can see that these are very powerful and they can approximate any generic function, whether it's AND or etc.